There are parties in conference, including you.
The site and message sent to Brigham and Women's Hospital, and it's to welcome everyone online to our Decide informational webinar on methods. Today we have a guest speaker, Jason Roy from University of Pennsylvania, who's here to talk with us about missing data and use of missing in perhaps in a comparative effectiveness context. So I'd like to pass it over to Jason Roy to speak with us.
Okay, thanks. So I'm going to talk about missing data, which is a very broad topic. So because it really depends on, handle missing data depends on what type of missing data you have, what you're interested in, for example, prediction versus comparative effectiveness. So I decided to just touch on a lot of different things quickly, including I have a few examples from things worked on as well. And then, during the question and answer period, we could, go into more detail. So that's my strategy here. So the line is basically I'm going to go to different situations and talk about assumptions and then some methods you might use for that situation. And then also, in some places, I'll go through examples. So we'll look at cross-sectional data where you have missing outcomes, and look at missing covariates, and with the longitudinal case, and focus mainly on dropouts. I'll discuss a little bit about some examples of missing data in healthcare databases, such as claims or EHR data, and give an example there. So that's the basic outcome. So start with the missing outcomes when you have cross-sectional data. So I'm not talking about dropouts here, but just study and so don't have an outcome observed. So we'll do some standard notation. So our M will be Y, and then if it's observed, we'll call it Y obs, and if it's missing, we'll call it Y miss. And because there's data, then we're also going to think about a variable that is kind of like the selection variable, so the indicator variable that, it's whether it's observed or missing. And we'll have covariate X. Okay. So then we can think about so the usual way about assumptions about missing data would have to do with this. What was the selection mechanism? So what determined whether an observation was observed or missing? And so we'll write it as, we'll think about the probability of, so shorthanding this, but you could think of the probability of your data being missing for an interval, that conditional on both mean and observed values. So it could be both missing and observed data. So if so it's just conditional on Y and conditional on X. But if that only depends on X, so this is the first case where we have the missing completely at random assumption. So if missingness really only depends on X, then we call that missing completely at random. So we'll call this different names for the case where it depends on covariates, because you could think of a more extreme case where missingness doesn't depend on anything, so there's just a coin flip. But other times people think of the missing completely at random cases depending on covariates. So the way you could think about it. And then there's this other case where missingness might depend on everything you observe. So X and X is really everything you observe, and then Y miss is what you don't observe. And we'll say the probability of missing doesn't depend on the things you don't observe. Okay, be missing at random. So in other words, for missing at random, if you condition on everything that you observe, then you have the missing data mechanisms specified as full as you need to, so it's not depending on other things. And then this other case, this missing not at random case, where, well, we can't simplify. So we'll have missing data in part because of the value of what the values would have been if it would have been observed. So you can imagine, you're in a your study that's looking at comparing different diets or and the goal is weight loss or something. And if somebody gains weight, maybe they drop out of the study, and if somebody doesn't gain weight, maybe they stay in the study. So they might depend directly on this value of y that's only partially observed. So that's a case that's obviously a bigger concern. Okay, so then I'll just quickly run through this slightly more technical slide just to get the basic idea of what we want to do and how we want to think about this. So if you were doing likelihood-based inference, then you would write down the likelihood for your observed data. Your observed data here, we're thinking of it as y obs and r. And you could also put x in there if you want. But then what you typically do then, if you're interested in you want to use your observed data likelihood to infer something about the parameter you're interested in, then you often start with a full data likelihood and then write out missing data. So this is the after the equal sign here is we're ending over the missing y values, and our complete data likelihood is what's after the integrable there, and includes the value of r conditional on y obs y missing x, and then also this data likelihood that involves y conditional on x. So we're interested in theta here. So theta is parameters that are involved with this relating y to x in case where there was no missing data. But then we need to integrate over this distribution of missing data, right? So if you assume missing at random, then with some simplification. So missing data mechanism no longer depends on y miss. So without that, then you could sort of pull that outside of the integral, and we would just integrate the this joint distribution y obs y miss. You would integrate out y miss, then you're left with the marginal distribution of y obs, and now you have these. We have a product of two likelihoods, and so if you're missing at random, the observed data likelihood is just proportional to the likelihood for your observed y, given x. Right. In that case, we could just ignore, since we have this proportionality, and analyze data, just your observed data, right? So say that r is ignorable in that case, because there's term r given y obs it doesn't involve theta, doesn't involve it doesn't involve theta, and we can separate it, so it's just proportional. Okay, so I argue that if you have missing outcome data in this kind of situation, that you're really mostly concerned about bias,